We are going to start now the chapter 3 of class 11th mathematics, trigonometric functions, and this is lecture 1. So we start this chapter with the definition of the angles. So we are saying, suppose we have a ray OA at this position. This is called the initial side. By keeping this vertex O, this point O, we are keeping this as fixed and it is called the vertex. We have rotated this ray OA and we obtain this ray OB. This is called the terminal side. This is the initial side, this is the terminal side, and when this rotation happens, we are saying this angle is formed. This is the initial side OA. This is we have rotated this ray along by keeping this point O fixed, and we are saying by this rotation we obtain an angle AOB, and it is represented like this, that it is angle AOB. This side OA, it is called the initial side. This side OB, this is called the terminal side. This point O, it is called the vertex. The amount of rotation from the initial side to the terminal side is called the measure of the angle. This is the definition of the measure of the angle. We are saying this measure of the rotation over here, it is called the measure of the angle. Next is positive and negative angles. So an angle formed by a rotating ray is called positive or negative. It depends upon whether we are rotating that ray in clockwise direction or anti-clockwise direction. So if we are rotating the ray in clockwise direction, then we are saying that the angle is negative. Clockwise direction means this is our initial position. We are saying either we can rotate this ray in this direction, we obtain the ray over here, or we can rotate this ray in the downward direction, we obtain the ray over here. So we are saying this angle, if we are measuring this angle, we are saying it is minus theta, and when the ray is rotated in the clockwise direction, this measure of this angle, it is measured as positive, it is taken as positive. This is just the convention we have, that whenever the rotation is taking place in the clockwise direction, we take it negative, and when it is taking in anti-clockwise direction, it is positive. This is just a convention. We have considered this thing universally. Next is measuring the angles. So there are mainly two systems to measure the angle. First is the degree measure. So if we are considering a circle, this complete circle we are talking about, suppose this is the initial position we have, this is the initial position, this is the vertex both, this is the ray OA we are talking about, and when this ray is making the complete revolution over here, we are saying the angle it is forming, it is 360 degrees. So we are saying what is 1 degree? 1 degree is basically this part of the circle we are talking over here. It is 1 by 3/60th of the complete revolution of a circle is said to be the measure of 1 degree, and it is written as 1 degree. Now further, if we consider the 1 by 60th part of this complete angle, then it is called 1 minute. It is represented as this, and 1 by 60th part of 1 minute, this is 1 by 60th part of 1 degree. This is 1 by 60th part of 1 minute, that is called 1 second, and it is written as 1 second. We define one right angle is equal to 90 degree, and angle measuring 180 degree is called a straight angle. So these are some basic terms that you already know. These terms you are already familiar with, because you know the whatever you have studied till now, it was using the degree measures. So on our next slide we have shown certain angles over here. We are saying in the first slide we have, this is OA line, initial line is there, this line OB is marked, and this angle over here it is 40 degree. This OA line is there, this 90 degree angle is there, this is called right angle. Then this OA initial line is there, this OB angle is there. When we measure this complete angle, the straight angle over here, this angle over here. We are saying up to this point, this angle is 180 degree. After this, further it is moving in this way. So we are saying the total angle at this point, this angle over here, this is 230 degrees. Now next we are saying we have this angle given over here. Look at this angle over here. We are saying first it started rotating. Suppose this is the initial ray OA we are talking about. This is the initial ray OA. It started moving or rotating by keeping this point O fixed. Suppose it has made a complete revolution. It has made a complete revolution. When it has made one complete revolution, it reaches again this initial position OA. Then we are saying it has traced the angle of 360 degree. Now after tracing, this thing is shown in this figure over here. Up to this point, it has traced the angle of 360 degree. After this, it has further rotated. After taking the complete revolution, it has further rotated, and the angle we obtain over here, that will be 420 degree. How we are getting this angle? We are saying this is basically 360 degree due to one rotation, plus further it has moved 60 degree. So the total angle we have over here, it is 420 degrees. Now in this next figure, the angle that is measured, it is in the clockwise direction. When we are talking about this third figure over here, we are saying how the angle is measured. We have started from this point A. We have started moving in the anti-clockwise direction and we have reached this point. We are saying this angle is 230 degrees. Now suppose we start from this point A and we move in the anti-clockwise direction. Then the angle will be 360 degree minus 230 degree. So the answer we obtain, that is equal to 130 degrees. Similarly, in this fifth figure, we are saying this OA is the initial line. We have started rotating this line OA, but now it is rotating in the anti-clockwise direction. It has reached this point, then it has reached this point, then it has reached this point, and finally we get this OB. So we are measuring the angle in the anti-clockwise direction, and the measure of this angle, it is minus 230 degree, because it is by our convention that whenever we measure the angle in anti-clockwise direction, we take the negative sign over here. Next, this initial ray OA is given. Again, it has rotated in the anti-clockwise direction. The measure of this angle we have, it is minus 30 degree. If we are measuring this angle from in the anti-clockwise, it is rotated in the clockwise direction. If we measure the angle in the anti-clockwise direction, the angle we will have, it is 360 minus 30 degree, that is equal to 330 degree. So this angle, when we are taking the rotation in anti-clockwise direction, it is positive. When we are measuring the angle in the clockwise direction, we have the negative sign over here. This is negative because it is in the clockwise direction. We have measured the angle in the clockwise direction. The next system of measuring the angle, it is the circular system or the radian measure we are talking about. So in this system, we are saying, suppose we have a circle, and from the center of this circle we draw an arc. This is, suppose this point, it is O is given. This is the initial arc we are talking about. This is OA, and the radius of the circle, it is R. Now if we take an arc of this circle whose length is equal to R, the radius of this circle is R. We are saying from this point A, we have taken an arc of the circle. The length of this arc, it is R units. Now we join, say this point, it is B, we have joined this point O and B. The measure of this angle AOB, this is called 1 radian, and it is written also as 1 radian. This is the symbol for the radian. Now the next result we have is, we have to prove that a radian is a constant angle. So let us consider a circle with center O and radius R. This thing is shown over here, and we are saying this AB be an arc of length R. The length of this arc AB, it is this. We have joined the points OA and OB, and this angle we are saying this is equal to 1 radian. Now if we produce this line OA in this direction, we are saying we have produced this to OC, where C is the point on the circle. Then we are saying that this complete angle over here, this angle will be a straight angle that will be equal to 2 right angles. So we know that the angles at the center of the circle are proportional to the lengths of the arcs subtending them. So we have this angle AOB. We are talking about this angle over here. This is AOB, this angle, over angle this divided by angle AOC. We are talking about this angle AOC. This should be equal to the length of the arcs. The length of this arc, it is R, and the length of this arc from A to C, the length of this arc, this is 2 pi r, that is the length of the complete circle, circumference, divided by 2. So it is pi into r. These two gets cancelled. So we are getting that angle AOB is equal to angle AOC upon pi, and we know that this angle AOC, this angle we are saying this is some constant value that is equal to 2 right angles. So this thing implies us that angle AOB, that is equal to 1 radian, that is equal to constant. What we mean to say is that when we are measuring this angle, the definition of this angle, it says that we have taken a circle of radius R. We have marked an arc over here whose radius is R. We have joined these 2 points, this point A, B and O is there. We are saying, we are talking about this angle over here. What is this R over here? This can change. We can take the circle of radius 1, we can take the circle of radius 2. In this theorem, when we are saying a radian is a constant angle, we want to prove that if this radius is changing, this angle is not changing. If one person is taking a circle of radius 2 units, he has drawn a circle of radius 2 units, he has marked an arc of 2 units, the angle he has drawn, the measure of this angle. Another person has taken a circle whose radius is 3 units, he has marked an arc over here of 3 units. Then the angle formed over here, both these angles, they are equal to each other. That is the measure of this radian. It is independent of the value of this R. This thing we have proved over here, that angle AOB, that is independent of the value of R, that is, it is always equal to a constant. Next is, in a circle of radius R, so a circle is given and it is given that the radius of this circle, it is R. If an arc of length L subtends, there is an arc of length, say this up to this point, B is there, and the length of this arc AB, the length of this arc AB, it is L, and this subtends an angle of, the angle at the center we have, it is theta radians at the center, then theta is equal to L over R. This thing we have to prove. Now what we know is, if the radius of this circle OA, it is R, suppose we mark the point over here, say this is the point C, where this length, arc length AC is equal to R. We join these 2 points O and C, then the measure of this angle AOC, this is 1 radian. Again, we know that the angle at the center of a circle are proportional to the lengths of the arc subtending them. So what we get is that angle AOB, this angle, divided by angle AOC. We are saying these are the two angles subtended at the center, and this should be equal to the ratio of the length of the arcs. So ratio of the length of the arc corresponding to this angle AOB, it is L, and length of the arc corresponding to AOC, it is R. What is the value of angle AOC? It is 1 radian. So we get that angle AOB, that is equal to theta. This is given to us that this angle is equal to theta radians, and this is equal to L over R. This is the value of theta we obtain. It is L over R. Now when we are talking about a complete circle, we are saying, suppose this is the radius of this circle, it is R. We know that if we subtend an angle over here, this arc length we are saying it is R, this is O, A and B. So the measure of this angle, this is 1 radian. Further we have, if we consider the arc length is equal to L and the angle this point C will subtend, say this angle is equal to theta, then the result we have seen that theta is equal to L over R. Now if we are talking about the whole circle over here, this complete circle over here, we have the length, this length L will be 2 pi R over R. It means we are talking about the measure of this complete angle we have. Now theta is this complete angle, so that is equal to 2 pi. So this thing is stated over here that a complete circle subtends at its center and angle whose measure is 2 pi radians. And when we are talking about degrees, it is 360 degrees. So what we are saying is that 2 pi radians, that is equal to 360 degree. We are saying pi radian is equal to 180 degrees. So 1 radian is equal to 180 over pi degrees. So these values, these are mentioned over here. We are saying that 1 radian, if it is given, it is 180 over pi degrees. Value of pi, if we consider 22 by 7, we get the approximate answer, it is 57 degree and 16 minutes. This is the value of 1 radian. Next, the opposite case we are talking about. If 180 degrees pi radians, then 1 degree will be equal to, this is the value we have obtained after solving this, it is 0.01746 radians. So some particular values that you should always remember, these are mentioned over here, that when we are talking about 360 degree, the measure in radians, it is 2 pi. You are saying when we are talking about 360 degree, that is equal to 2 pi radians. Now the half of this, it is 180 degree, so that is equal to pi radians. The half of this, it is 90 degree, that is equal to pi by 2 radians. The half of this, it is 45 degree, that is equal to pi by 4 radians. Now if we have to calculate the value of 360 degree in radians, what we have to do? We have the conversion 1 degree, that is equal to pi by 180 radians. So 30 degrees will be equal to pi by 180 into 30, and this comes out to be pi by 6 radians. So this value is there, it is pi by 6 radians. Similarly, if we have to calculate the value for 60 degree, it will be 60 over here. The answer we will obtain, it is pi by 3 radian. So these are some standard values that you should always remember, that 30 degrees pi by 6 radians, 45 degrees pi by 4 radians. We not always mention pi by 4 radians, we just write it as pi by 4. It is symbol, this pi by 4, we are saying this thing is not always necessary to mention over here. This symbol for the radian is not necessary to mention over here. If we are writing pi by 4, it is sufficient to write pi by 4 to represent pi by 4 radians. This thing is mentioned over here, that theta radians is represented by the symbol theta only. Now the next question we have is, find the degree measure corresponding to each of the following radian measures. The first question we have it is 7 pi by 12 radians. So we know that pi radians is equal to 180 degree. So this implies us 1 radian is equal to 180 over pi degrees. We want to calculate the value of 7 pi by 12 radians. So the answer we obtain, that is corresponding to this value, it is 180 by pi into 7 pi by 12. It is equal to 105 degrees. Second question, we have to convert this value 3 by 4 radians. So again we have this formula, so we get the value corresponding to 3 by 4 radians, that is 180 by pi into 3 by 4 degrees. This comes out to be 180 into 7 by 22 into 3 by 4 degrees, and on solving this we will obtain this answer. So these calculations, these are shown over here. We are saying this value we are talking about, it is 18 into 7 by 22 into 3 by 4. So when we calculate this value, the answer we obtain, it is 42.9545 bar degrees. This, it is basically 0.4545, it will keep on repeating. So if we are writing this in this form, this value we are talking about, if we are writing it in this form, we have truncated the value at 45 over here, and we are writing the answer up to 4 decimal places. We can write it in the form, this is equal to 42 degree plus 0.9545 degrees. Now this 0.9545 degree, when we convert it to minutes, we get the answer in this form. This value we have converted into, this degree is converted into minutes. So on multiplying this value, we obtain the answer, it is 57.2727 minutes. Now look at this value over here, 57.27 minutes. We can write it in the form, it is 57 minutes we have separated, and this part 0.2727 minutes we have, and we have converted it into seconds by multiplying it with 60. So the answer we obtain, it is 42 degree plus 57 minutes plus 16.36 minutes, and we are writing this value 16.36 minutes as approximately equal to 16 minutes, and we are obtaining this answer over here, it is 42 degree 57 minutes and 16 seconds. Now in place of this, suppose we have truncated the value up to 42.95. this thing is shown over here, it is 42.95 degrees we are talking about. So when you convert this value, this 0.95 degree, when you will convert, you will get exactly, it is 17 minutes. So the answer in this case we are obtaining, it is 42 degrees and 17 minutes, and we are saying these two values, these are approximately equal to each other. This 17 minutes we are obtaining, it is not 17, it is 57 minutes we are obtaining, and this is approximately equal to 57 minutes and 16 seconds. Now suppose in place of this, you have rounded this figure, you have round off this figure to this value, you have rounded up this figure, it is 42.96 degrees. The answer you will obtain, it is 42 degree 57 minutes and 36 seconds. So all these answers are approximately equal to each other, so we can write the answer in this form, that it is 42 degree 57 minutes and 16 seconds. Why I have shown you these calculations, that there might be a difference in your answer when you are doing the calculation, because what value you are considering over here. If suppose if someone consider in place of this 22 by 7, this value we are saying, in place of this 22 by 7 someone considers 3.14, he will obtain a different answer. So you need not to worry for that much error in the answer. That is just because of our calculations. Next is we have to calculate the value for minus 2 radians. So the answer we are obtaining, it is 180 by pi into minus 2 radians. So on solving this, the answer we will obtain, it is shown over here that it is 114 degree 32 minutes and 44 seconds, and it is negative sign over here. This is negative sign over here. Next is find the radian measure corresponding to each of the following degree measures. Now we have to convert the degrees to radians, and we know that 180 degree, that is equal to pi radians. It means 1 degree, that is equal to pi by 180 radians. Now first part we have, it is 15 degree. So the answer we obtain corresponding to 15 degree, it is pi by 180 into 15, and that comes out to be pi by 12 radians. Next part we have, it is 240 degrees. So it is pi by 180 into 240, and the answer comes out to be 4 pi by 3 radians. We need not to write radian over here, we can just write it like 4 pi by 3. When we are talking about 1, this is 37 minus 37 degree and 30 minutes. So first of all we are converting this value into degrees. So the answer we obtain, it is minus 37 degree minus 30 minutes, it is into 1 by 60 degree. This answer comes out to be 2. So on multiplying this value we will get this is equal to minus 37 degree minus 1 by 2 degree, and this is equal to minus 75 by 2 degree. So when we convert this value, the answer we obtain, it is pi by 180 into minus 75 by 2, and this comes out to be minus 5 pi by 24 radians. This is our final answer that we obtain in this case. So these are how we can convert the values of degrees to the radians. Next is find in degrees the angle subtended at the center of a circle of diameter 50 centimeter by an arc of length 11 centimeter. So the length of this arc, it is 11 centimeter. The radius is given to be 25 centimeter. Suppose the angle it subtends at the center, it is theta degrees. Then we know that the value of theta, it is equal to L over R. The answer comes out to be 11 by 25 radians. We have to find in degrees, we have to convert it to degrees. We know that 1 pi radian is equal to 180 degree. So 1 radian is equal to 180 over pi degrees. So 11 by 25 radians, that is equal to 180 by pi into 11 by 25 degrees. So when we solve this value, the answer we obtain, it is 126 by 5 degree, and this comes out to be 25 degree and 12 minutes. Why? When we are dividing this value, we are writing it is 126 by 5 degrees. So that is equal to 25.2 degrees. This is equal to 25 degree plus 2 degree. When we convert it to minutes, we are saying we have multiplied it with 60 over here, and the answer we obtain, that will be in minutes. So it is 25 degree plus 12 minutes. So this is our final answer, and it is 25 degree and 12 minutes. The next thing we have is find the radius of a circle in which the central angle is 72 degrees and the intercept an arc of length 22 centimeter. This length is 22 centimeter. Suppose the radius of this circle, it is r centimeter. Now by suppose this angle over here, it is theta, radians, and we know that this theta radian, that is equal to L over R. It is important to note over here, this is theta radians, but the angle given to us, it is in terms of degrees. We cannot write 72 over here. We have to convert this 72 into radians, and how many radians are there? It is 72 into pi by 180, that is equal to, length is 22 and radius we have to calculate. So the value of R we obtain, that is equal to 180 into 22 by 72 into 22 by 7. These two values get cancelled, and the final answer we are left with, it is 35 by 2 centimeter, and that comes out to be 17.2 centimeters. I am again repeating this thing. The angle given over here, it is in degrees, and this formula that we have, it is only, this is the definition from the radians that we have. It is not for the degrees. If you are writing 72 is equal to L over R, this thing is wrong, because this formula is not valid for degree measures. Next is the minute hand of a watch is 1.4 centimeter long. How far does its tip move in 45 minutes? So we are saying, you suppose it is at this point, this is the initial point given to us. In 45 minutes, first of all, it is rotating in the clockwise direction. So the angle measure we have taken, it is negative angle, but we have to measure how far does its tip move. So we are talking about this angle over here, so that will be, I am talking about this angle over here. So this is the initial point O. This angle over here, this will be minus 180 degree. Further, this angle over here, that is 45 degree. Now we are not writing the angles in terms of degrees, we are writing the angles in terms of pi. So it is minus pi. This angle, it is minus pi by 2. This is a further 90 degree angle is there, so it is minus pi by 2. So this total angle that we have over here, this total angle we have over here, it is minus pi by 2. That comes out to be minus 3 pi by 2 radians. Now the radius, it is given to be this. Suppose this value we are saying it is 3 pi by 2, the angle that it has moved, that is equal to, we have to find the length corresponding to this. We are calculating the length, so we are taking the mod over here, we are taking the positive value, minus 3 by 2 mod, that should be equal to L over R. The value of radius is given to be 1.4, so the value of L that we obtain, that is equal to 3 pi by 4 into 1.4. This comes out to be 3 by 4 into 22 by 7 into 1.4. On simplifying this, the answer we will obtain, that is equal to 6.6 centimeters. Now the next question we have is, if the arcs of the same length in two circles subtend an angle of 60 degree and 75 degree at their respective centers, these are the centers of the circles, we have to find the ratio of their radii. So the arcs, they are subtending the same length at the center. If this length AB is L, then this length CD is given to be L. So corresponding to this, if this angle it is theta, radians we are talking about theta 1 radian, and this angle we are saying this is theta 2 radians, then we have the value of theta 1, that is equal to L over R1, and the value of theta 2, that is equal to L over R2. Now the angle that is given to us, it is in radians, so the value that is given to us, it is 60 into pi by 180, and this value is given to be 75 into pi by 180. Now if we divide both these equations, this L and L gets cancelled, pi by 180 gets cancelled with pi by 180, and what we are left with is that R2 over R1, that is equal to 60 by 75, and this comes out to be 4 by and this is the ratio of the radii of the two circles. We are saying r1 over r2, that is the ratio of the first radius to second radius, 5:4. Next is angles of a triangle are in AP, and the ratio of the number of degrees in the least to the number of radians in the greatest is 60:pi. Find angles in degree and radians. So let the angles of the triangle, they are given to be in AP. So we are considering that one angle is A and other two are A minus D and A plus D. Now it is given that the ratio of the number of degrees in the least to the number of radians in the greatest is 60:pi. So the least angle, it is, first thing that we have is A minus D plus A plus A plus D, that is equal to 180 degree. So this D gets cancelled and we get the value of A is equal to 60 degree. So the angles we have, it is 60 minus D, 60 and 60 plus D. The least of these values, it is 60 minus D. This is the least value, and the greatest of all these values, it is 60 plus D. So the ratio of these two values, and another thing given over here, that the ratio of in degree the least value and in radians the greatest value. So we convert this to degree also, and the ratio is given to be 60/pi. So this pi gets cancelled. So what we get is that 60 minus D is equal to 60/180 into 60 plus D. So we get 180 minus 3D is equal to 60 plus D. On solving this, we will get the value of D is equal to 30. So the required angles are 30 degree, 60 degree and 90 degree. Now we have to find the angles in degree and radians. When we convert these values to radians, the answer we will have, it is pi by 6, pi by 3 and pi by 2 radians. Next is in a right angled triangle, the difference between the two acute angles is pi by 50. So suppose the triangle is given to us, this is right angle, then one of the angle we consider it is x and second it is y. The difference between these two angles, it is given to be pi by 15, and the sum of these two angles x plus y, that we will have, it is 90 degree, that is equal to pi by 2. So we have to find the angles in degrees. So this angle in degree, it is 90 degree. So if we convert this value to degrees, it means we have to multiply it with 180 by pi. We have to multiply it with 180 by pi because we want the answers in degrees. So this pi gets cancelled and these two values get cancelled, and the equation will become, this is equal to 12. Over here this pi gets cancelled and this value will become equal to 90. So the values we have now, equations we have, it is x minus y is equal to 12 and x plus y is equal to 90. Adding these two equations, we get 2x is equal to 102. So this implies us x is equal to 51, y is equal to 39. So the three angles that we have, they are 51, 39 and 90 degrees. Next is a wheel makes 360 revolutions in 1 minute. We are talking about a wheel is there, it is rotating like this. So this is the initial point we are talking about. It makes one complete rotation. This point, it again reaches at this point, it again reaches this point, touches the ground over here, and in 1 minute it has made 360 rotations. Through how many radians does it turn in 1 second? So in 1 minute we are saying it is rotating, making 360 revolutions. So we are saying in how much time it will make one revolution, we want to find this. So we are saying in 60 seconds it is making 360 revolutions. In 1 second it will make 360 by 60 is equal to 6 revolutions. Now how much radians does it turn? 6 revolution means in the first revolution, and it has made 1 revolution, the radians it has turned, it is 2 pi radians. Then again it has made the second revolution, it has moved 2 pi radians, it has turned 2 pi radians. Likewise 6th time it will turn 2 pi radians. So the total angle it has moved, or radians does it make, it is 6 into 2 pi, that is equal to 12 pi radians. Next is find the angle between the minute hand and the hour hand of a clock when the time is 7:20. So we are talking about a clock is there and the time on that clock it is 7:20. This is our minute hand, this is our minute hand, and this is our hour hand. We are saying it is at 7 and this is 20 over here. So we are saying the angle traced by the hour hand in 12 hours. We are talking about this hour hand in 12 hours, it is 360 degrees. Now the angle turned by it in 7 hours and 20 minutes. How much is 7 hours and 20 minutes? It is 7 plus 20 by 60 hours. This is 3, so this is equal to 22 by 3 hours. So how much it has moved? It is 360 by 12 into 22 by 3, that is equal to 220 degrees. So we are saying this angle over here, this is 220 degrees. This is our initial line over here. This angle we are talking about, this is basically, it is, we are measuring in this direction, so it is minus 220 degree. Now in the second case we are talking about angle traced by the minute hand in 60 minutes. When we are talking about in 60 minutes, the angle traced by minute hand, it is 360 degree. Now we are talking about it has moved 20 minutes. So the angle traced will be 360 by 60 into 20, that is equal to 120 minutes. This angle we are talking about, this is 120 minutes. So this whole, the required angle, it is this much angle. So this angle will be minus 220 degree plus 120 degree. It is minus of this, and the answer comes out to be minus 100 degree. This minus sign just represents that we are measuring the angle in the clockwise direction. So if we are talking just about the angle between the two hands of the clock, so the answer will be 100. We need not to write minus sign over here. We are just saying the angle between the two hands of the clock, it is 100 degrees. Next is a horse is tied to a post by a rope. A post is there, this P is given, and the horse is tied with a rope. This is the rope we are talking about. If the horse moves along a circular path, always keeping the rope tight, and describes 88 meter, this length, it is moving in the circular path and it can describe 88 meter. When it traces, the angle that it traces for this 88 meter, it is 72 degree at the center. We have to find the length of the rope. So suppose we are saying the length of the rope, it is r, and this angle, it is theta radians. Then we know that theta radians, that is equal to L over r, that is equal to 88 over r. And what is this theta radians? The angle that is given to us, it is 72 degree. So it is 72 into pi by 180. So the value of r we obtain, it is equal to 88 into this value we are saying, it is 180 into 7 by 22 upon, this is 72 into 22. So when we multiply these values, suppose we are talking about this, so we cancel this with 9. So we are getting 8 over here and 20 over here. Then it is 5 by 2. So this value gets cancelled, we are left with this 44, and over here we are left with this 2. So the final answer we will get, it is 70 meters. So we are saying the length of the rope is 70 meters.